By doing what? What is it doing?
Does it break down the probe?
It removes energy.
Break down this something in the cell?
Well, what happens when a freeze comes onto a plant? What's a plant mostly made out of? Water. What's any cell mostly made out of? Water. And what does water tend to do when it freezes?
It freezes.
It expands, that's true. It forms crystals, right? What do you think that might do to a cell?
Break it apart?
Oh, we can freeze that. That's what the freezer is for.
That might be good, right?
Yeah.
So, if we take our little bacteria cell, put lysozyme in there, so we can break down all that wonderful cell stuff, and let's use some ice. Let's freeze it. And by doing those two steps, we have a pretty good certainty that we'll get rid of most of what's in that cell. Or we'll at least release what's in that cell. We'll break down those cell walls. So then we have that wonderful solution of proteins that you want. By the way, just a hint for success in all your classes, when's the time of the semester to do awesome?
Right now.
Right now.
Yeah.
At the beginning.
What are the
Most people blow off the beginning and then at the last minute at
What are
the
the
end
triangles?
try to bring up a grade that has a huge sample already.
What are the triangles, Isler?
Triangles are the proteins that are
Okay.
just sitting in there. Because there's other proteins. Okay, we're going to do something called hydrophobic interactions.
Okay, so once I get my...
And you're going to make molecules more hydrophobic in certain situations and less hydrophobic in certain situations.
This is chemistry, isn't it?
Oh, it's chemistry, all right. Yes. You're going to love this chemistry. Those of you who have chemistry are going to have a little advantage in this unit here because you're going to understand the terminology a bit better. So I'm just going to give you a quick overview of what we're going to do here. So the supernatant we're talking about over here are all the wonderful stuff that's going to come out of the cell when we do the lysozyme and the ice onto the cell. And we have these columns here that you're going to wash the wonderful stuff through. So you're going to pour all of that into these columns. And then notice what happens. We're going to get a lot of that liquid to go through. And fortunately, we're going to have a substance, and we'll talk about that substance, in this column that's going to collect our wonderful little GFP and certain other proteins. So it's going to stick to those things in the column.
Wait.
Yes, I'm waiting.
This is probably what I'm doing with my tan problem.
Awesome.
Took
I took everything that we got from destroying the bacteria,
Hey.
and it's over there in that little tube, and I'm going to pour it through this column with these little tiny beads in there.
Hey.
And those proteins are going to stick.
What did you originally call that column right there?
This column?
Yeah.
Supernatant?
You can call it a chromatographic column.
Oh, what was the other one? The super...
We'll get into the details later.
Oh no, I did have a
This
chromatic.
process is called column chromatography. It's just a little piece of plastic.
Can I have one?
Do you have it? I would assume so.
I want one.
Okay. We're going to get one for the lab. We're going to have lots of these. Okay, we're going to put low salt buffer, which is going to do some wonderful things as you're watching. So dump it in the column, and obviously it's going to start moving through the beads. And because we use that low salt buffer, guess what? Right, we're going to push through the GFP. It's the only protein that we want. So the GFP protein is going to come off the beads, and we're going to have it as our end product down there. What are those beads? They're a resin or plastic bead that has a certain charge on it, and we can charge it differently each time we do a wash.
So what is the regular charge on
What's that? Right, it has an attraction for the proteins that go through.
So this whole process is just to separate the GFP from the other proteins we don't like?
Exactly.
And how does it recognize the GFP different from the other proteins?
We force it to recognize the buffers.
Okay.
So the affinity for the proteins that those beads have is changed by whatever buffer we put in there.
Okay.
Because we're changing the actual protein's affinity for the bead.
What's that machine right there with purple in it?
That's the UV light. I turned it on so you can see this glow in the dark. Let's turn it on.
That was clever.
Pretty good, huh? You like it? You like it? Okay.
I'm gonna have to re-listen to this lecture.
All right, let's pick up on this tomorrow. We'll go over protein structure. And I'm going to have you guys do a little in-class research as we do this, okay? So if you want to get a head start, I want you to find the 4 types of protein structure for tomorrow, and we'll talk about them. We're going to do some origami. How does that sound?
Oh, I'm horrible at it.
You're horrible at origami?
I used to be able to make pigeons, but that was about it. Folding paper was beyond me.